Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. In this video, we're going to continue our deep dive into pygame blending modes. Blending modes specify the color and transparency value of a result pixel when you blit a source pixel to a destination pixel. In the first video, we looked at the default blending mode and the add blending modes, blend add, blend RGB add, and blend RGBA add. We also covered the basics of color representation, creating and blitting surfaces, and how to achieve transparency on a pygame surface. Check out the first video if you'd like a refresher on those topics before we jump into our next blending mode. I'll put a link right here and in the description. Now, on to our next blending modes, the subtract modes. When we blit a source pixel to a destination pixel with a subtract flag, either blend sub, blend RGB sub, or blend RGBA sub, the color values of the source pixels are subtracted from the color values of the destination pixels. If we use blend RGBA sub, the alpha channel value is also subtracted. In all sub modes, the channel values cannot go below 0. Blend sub and blend RGB sub work the same. They subtract the source pixel color values from the destination pixel color values, leaving the alpha the same as it was on the destination surface. You may remember from the last video that when we create a surface, every pixel has a default RGB color of 000 black. If we pass it the pygame.src alpha flag when we create it, every pixel will also have a default alpha value of 0 or transparent. If we don't pass that flag, the default alpha value will be 255, fully opaque. Let's look at some examples of how the blend RGB sub mode works. This program is called blend examples sub.py, and it is available in my GitHub repository. There's a link in the description. I'm loading in some images, a background image of a dystopian city, which is a JPEG with all opaque pixels, and a blimp image that is a PNG, opaque pixels where there is a blimp image, and then all around that is transparent white pixels. I'm also creating two surfaces to blit to, working alpha and working opaque. I'm creating working alpha passing the pygame.src alpha flag, meaning the color will be 0000, transparent black for all pixels. And I'm creating working opaque without passing that flag, meaning the color will be 000255, opaque black for all pixels. I have a flag, blit opaque, that I set to true when I want to blit the working opaque surface at the end of the code, and false when I want to blit working alpha. At the end of the compositing code, I'll blit one or the other to the screen, depending on how the flag is set. We don't want to composite onto the surface created with set mode, the one I've called screen, because its compositing rules are different. Let's start with blend RGB sub, which leaves the alpha channel of the destination surface untouched for all pixels. I'm going to blit to the working opaque surface. The first thing I'm going to do is just blit that background image to the working opaque surface using special flags equals pygame.blend RGB sub. Given what I've told you about this blitting mode, what do you think will happen? Imagine I have a pixel in the background, the source surface, that is 139, 163, 167, 255. And the pixel at the same location in working opaque, the destination surface, is 000255. Color channel values are subtracted, and the alpha remains what it was on the destination. So if you predicted I'd get a black result, you're correct. We can't have a negative color value, so when we subtract 139 from 0, for example, we are left with 0. Let's fill the working opaque surface with white. A white pixel is 255, 255, 255, and the alpha is still 255. What do you think will happen when we blit the background surface with the blend RGB sub mode? Let's run it and see. Did you predict an inverted image, something that looks like a negative? If so, well done. That's what we get. Now, how is that happening? Let's take a sample pixel at coordinate 232, 107. Before we blit, in the destination surface, that pixel is white, 255, 255, 255. In the source surface, that pixel is 139, 163, 167, a sort of light bluish gray. Now, after the blit with blend RGB sub, the resulting pixel is 255 minus 139, 255 minus 163, 255 minus 167, or 116, 92, 88. a sort of dark reddish brown. The lighter colors become darker colors, and the darker colors become lighter colors, all according to the mix of red, green, and blue in the original color. If we have a white pixel in the source, 255, 255, 255, it will be black in the result. 255 minus 255 is 0, and 0, 0, 0 is black. And if we have a black pixel in the source, 0, 0, 0 will be white in the result. 255 minus 0 is 255 of white. A straight blue, 0, 0, 255 will become yellow, 255, 255, 0. Now, that's if we're subtracting from white. If you start with a darker color, like a gray, then you'll get a darker negative. And here, I'm starting with a yellow and blitting the background image. And I get a yellow-tinged negative. This is fun to experiment with. You might remember that if I blit a dark gray surface over an image with a blend add mode, it lightens the image. What if we blit a dark gray surface over an image with a blend sub mode? I have a surface called filter surf that I'm filling with a gray, 100, 100, 100, and then I'm going to blit that over the background using blend RGB sub. And when I run that, you can see it darkens the image. That's because we're subtracting 100 from every color channel of every pixel, and lower color numbers are closer to 0 and will appear darker. What if we do that for just a piece of the image? I used an image called Spotlight in the last video, all black with a gray circle, the spotlight. When adding, the gray circle brightened the pixels it was blitted over. I have here an image called Reverse Spotlight, all gray with a black circle. When I blit this over the background using the Blend RGB Sub blending mode, it darkens all of the image except where the black circle is, since subtracting black, 0, 0, 0 from a pixel will have no effect on it. This gives an eerie effect, as most of the image is in shadow. Let's talk about Blend RGBA Sub. This mode works like Blend RGB Sub, but it's also going to subtract the alpha channel. This will only have an effect if we're working with a destination surface that has a per pixel alpha, one that was created with the pygame.src alpha flag, or a surface that we have sent the convert alpha message to. If we use an alpha blending mode on a surface that doesn't have per pixel alpha, the result will be as if we were using the equivalent non-alpha blending mode. So to illustrate Blend RGBA Sub, we'll switch to the working alpha surface, and I'll ensure that's the surface that gets blitted to the screen when we're finished compositing by setting the blit opaque flag to false. Blend RGBA Sub subtracts the opacity of part of an image as well as the color pixel values. If we have a source surface with fully opaque pixels, we will end up with a fully transparent result. Subtracting 255 from the alpha on the destination surface will leave us with a 0 alpha for all pixels in the result. So this is useful if we want to fade part of an image or fade it over time. Suppose I want to fade my blimp, but I want it to turn a color as it fades. So maybe it's heating up or rusting or rotting away. I'm first going to create a mask of the blimp. The blimp, remember, has all opaque pixels where the blimp is, and then around the blimp are all transparent pixels. A mask created from an image with transparent pixels will have set bits, where the pixels are opaque, and unset bits, where the pixels are transparent. I can then create a surface from that mask and specify the color of the set bits and unset bits. So I'm creating a mask and then turning that into a surface called Blimp Fader. The set color is 0, 2022, and the unset color is 0, 0, 0, 0. If we use that mask to subtract, nothing will be subtracted from around the blimp. But where the blimp is, we'll fade it slightly, subtract 2 from the transparency, and we'll make it a little more red, subtract 20 from the green and the blue components of each color. So I am using that blimp fader to create a faded blimp image. I'm blending it onto a surface called Faded Blimp so I can leave my original blimp image as it is. I'm using the Blend RGBA Sub mode to blit it. And once I have that faded blimp image, I'm using the default blending mode to blit that over the background. As it fades, more of the background will show through with the default blending mode. Blitting it once isn't going to do much. I have some code at the bottom that will repeatedly fade this in the game loop. So if I run the program, you can see it fading. Each time through the game loop, it's blitting the blimp fader to the faded blimp with the blend RGBA submode, subtracting more green and blue color and more opacity from each pixel, and then blitting that to the background and flipping. I've also put the code in the event loop. It will do one blit on a mouse click. It's also printing some pixel values so we can watch the blend mode in action step by step. So if I comment out the game loop fading and run it again, we see the starting image and a pixel within the blimp with a value of 242, 233, 202, 255. The faded blimp hasn't been blitted yet, but you can see its values, 242, 213, 182, 253. That's nothing subtracted from red, 20 subtracted from blue and green, and 2 subtracted from the alpha. I used 2 so I'd get a really slow fade. You can also subtract a larger alpha amount and use a counter and mod it by some number to slow down a fade in the game loop. Now I'll click once in the window, and the blimp turns a little pinkish. The faded blimp has been blitted to the working surface, and you can see the new faded blimp, the one that will be blitted next time, is 242, 193, 162, 251, subtracting another 0, 20, 22 from the prior values. I'm also printing the working alpha surface at the same pixel, and that's 241, 213, 182, 255. Because of the slight transparency of the blimp now, some of the background image pixel values are being mixed in with the blimp colors according to the formula I showed you in the last video, giving us a color that's a little different from the blimp color we're blitting. As I keep clicking, you can see the blimp slowly turning red and fading, and you can also see the color values going by. As we see the background showing through a very red transparent blimp, you can see a faded blimp alpha down below 200, and we no longer have any blue or green in the pixel we're examining. The color is 242, 00, 155. Again, this code is in my GitHub repository so you can play with it. Maybe change the amount of color you're subtracting from each color channel in the blimp, or add an effect around it besides the fading. I've got a video on some cool effects you can create with masks, such as glowing, that might pair really well with this subtractive color fade. I know this can be a little confusing and tricky to master. The best way to learn is to practice. Let's do a quiz to get you started practicing with the subtract blending modes. I might sneak something from the last video in here to keep you on your toes. You can pause the video and think about your answer before I reveal the correct answer. On the left is the destination surface created with dest equals pygame.image.load background.jpg convert alpha. No tricks, it's the same full opacity JPEG from the video. And in the middle is the source surface, reverse spotlight, loaded with pygame.image.load reverse spotlight.jpg.convert alpha. This is again the same full opacity JPEG from the video. It is dark gray with a black circle in the upper left. And here's my result surface on the right, created with dest.blit, source, 00, and then a blank. In the result surface, we can see the background image, but it's dimmer with a light circle corresponding to the black circle in the reverse spotlight image. What goes in the blank? Is it A, nothing, the default blending mode, B, special flags equals pygame.blend RGB sub, C, special flags equals pygame.blend RGBA sub, or D, this cannot be achieved with what we've learned in this video? Pause and work it through. Did you get it? The answer is B, pygame.blend RGB sub. This mode will subtract the color channel values in the source surface from the color channel values in the destination surface, but it will leave the alpha as it was on the destination surface. The black pixels are all 0, so nothing is subtracted in the circle. But where the image is dark gray, 100 will be subtracted from each color value, effectively darkening the pixels. Ready for another? On the left is the destination surface, created programmatically with dest equals pygame.surface size, and then filled with dest.fill 255, 255, 255. This surface has no alpha channel. In the middle is the source surface, created with source equals pygame.image.load background.jpg convert alpha. This is the destination image from the prior question, and again, it's a fully opaque image. On the right, we have the result, which looks like a negative of the source. Now we're combining these again with dest.blit source 00 blank. What goes in the blank? Is it A, nothing, the default blending mode, B, special flags equals pygame.blend RGB sub, C, special flags equals pygame.blend RGBA sub, or D, this cannot be achieved with what we've learned in this video? Pause and work it through. Did you get it? Once again, the answer is blend RGB sub. By subtracting each color channel of each pixel from white, we get an inverse of the color. The opacity remains 255 or fully opaque. How about one more, a challenge? In the video, I created a mask of the blimp and then created a surface from the mask. I applied that surface to the blimp using blend RGBA sub, and then I blitted that over the background using the default blending mode. When I created the surface from the mask, I passed as arguments an unset color and a set color. If this is my result after one blit, a ghostly cyan blimp, what were the unset color and set color arguments? Were they A, set color equals 100, 0, 0, 100, unset color equals 0, 0, 0, 0, B, set color equals 0, 0, 0, 0, unset color equals 100, 0, 0, 100, C, set color equals 0, 255, 0, 255, unset color equals 0, 0, 0, 0, or D, set color equals 0, 255, 0, 150, unset color equals 0, 0, 0, 0. Pause and work it through. So what do you think? What is going to give us that ghostly cyan blimp? If you said A, you're correct. Subtracting red from the blimp pixels while fading it to an opacity of 155 will give us a ghostly blimp that is tinged more to the green and blue, or cyan. You might download my code and make predictions about what the other set and unset colors will do, then change the arguments to the call and confirm your predictions. I hope you enjoyed this video and the quiz. Stay tuned for more blending modes in an upcoming video. As always, have fun and keep coding.